Okay, hey y'all. I'm here today to talk to you about video game development. And at this point you might be thinking, and rightly so, like, uh-oh, is this guy at the wrong conference? But no, actually I'm at the right conference because I'm here to talk about video game development with Elixir. But still though, like, why? Why? Why am I here talking about this particular topic? To help answer that question, allow me to introduce myself briefly. My name is Nick. I use he, him pronouns. By day, I'm a software engineer at Gridpoint, where I'm using Elixir, Nerves, and Phoenix, and the whole lovely ecosystem day to day. And by night, I'm a hobbyist game developer. You can get me on the interwebs if you want to talk. This photo that I chose of myself is me as a child just experiencing pure joy. It's probably the coolest I'll be, so that's one of the reasons I chose it. But the other reason is because my interest in playing and making games started at a very young age. In the late 1980s, I got a Nintendo Entertainment System and just kind of became enamored of the medium as a whole. I quickly discovered games like The Legend of Zelda, where you were put into a fantastic world, explored dungeons and discovered treasure and fought monsters, and that really sort of like scratched an itch I didn't know I had. And then eventually I came across this game, Rogue, which is where this particular story actually begins. The thing about Rogue, for me, that set it apart from many of the other adventure games I played was procedural generation, right? So the way Rogue works is that many of the core gameplay elements, like the dungeons you explore, the treasures you find, and the monster encounters you have, they're actually procedurally generated by a computer algorithm rather than pre-planned by the game designers. So this sort of leads to each play experience being unique. And when you got a game over, that was it. That world was lost to time. You'd start again with a whole new world and a whole new sort of one-of-a-kind adventure. This is maybe the photo opportunity for you if you want to take a photo. This is probably the only gigantic slide that's going to say permadeath in red letters at ElixirConf, maybe ever. And maybe I'll never speak again here, but there it is. It turns out there was a similar phenomenon happening in the analog game space at this time. So namely Dungeons and Dragons and that sort of thing. So here's a tabletop game, not a digital game, where many of the core components were not planned or conceived by the game's creators. But in this case, though, instead of a computer generating this content, the other players that were at the table were generating the content. So you sort of replace the computer with your buddies here. And I thought that was pretty cool. Games as a collaborative medium is something I'm super interested in. So recently I've been exploring building a video game, that combines the generated and unforeseen outcomes of Rogue with sort of the social storytelling aspects of Dungeons and Dragons. So in short, I want to make a roguelike game where instead of a computer generating the content, the other players do it. I'm calling this a real-time, multi-modal, collaborative adventure game. And I'll delve a bit further into this somewhat obtuse, very obtuse, maybe this was a mistake, label in a bit. I love building things in Elixir, and I don't just mean writing Elixir code. I mean actually using all of the unique and interesting building blocks that OTP and the Beam give us. So when I was thinking about this sort of concept, I obviously asked myself, can I build it in Elixir? Can I use the language and the tooling and even some of the libraries that I use on a daily basis to start building out this concept I have in mind? Since I use Elixir at work and on most of my side projects, this is going to help reduce context switching for me so I can actually maybe finish a side project for once. Not to mention Elixir actually seemed like a good fit for some of the things I had in mind for this project. So yes. It turns out that yes, I could build this in Elixir. So I'd like to spend some time talking about the small prototype that I put together, sort of the seed of this idea. We'll go through some practical examples of the way I've solved some game dev challenges in Elixir, and some useful Elixir libraries, some of which may seem pretty obvious once you see the sort of requirements around the game, and some maybe not. And then hopefully, most importantly, so I'm going to empower folks that are working in the Elixir ecosystem to like get out there and build some games, because you can do that actually. So I come from a non-traditional programming background, and so I often thought this kind of thing was off the table. I came from a background in art and graphic design, and it wasn't until a good buddy of mine, a talented programmer who I was pairing with quite frequently on game projects, sort of doing the art side while he was doing the programming, kind of gave me the gentle nudge that like, hey, you could do programming. So now I do programming. So if you're an Elixir engineer, which I suspect most of you are, probably, seems like a safe bet, I hope that you'll leave this talk feeling like you can make some games. So before we get into the meat of the talk, let's align a bit on the concept of this game that we're going to be theoretically talking about. So mostly I want to dissect this absolute mouthful. So cool. Here is a phrase that hopefully convinces some of you that, hey, this actually might be a talk about Elixir. In this context, real-time means that players will be exploring and creating the world simultaneously on separate devices, and that the state of the world needs to be kept in sync across all those connected clients. Multi-modality in this context. The core concept here is that the user interface, the portal sort of that the players will use to interact with the game, will vary from player to player. If you're sort of playing the main game client as the adventurer, you're going to have a very different set of tools, user inputs, you'll be on a different device. So that's that. We can imagine a scenario where player one is controlling the adventure and moving around and making decisions about how to explore the world, and then player two at the same time is creating things that the adventurer could encounter. And of course, this could be more like 4 or 5 people playing together, with one as the adventurer and the other sort of creating the world as they go. And then this collaborative bit is just to say that this is a sort of a collaborative storytelling experience. It's not about competition or points or glory or anything like that. So yeah, there's that sorted, kind of. Those are the 3 things I kind of wanted to focus on when coming up with this prototype. And now that we have sort of like maybe a tenuous handle on what we're trying to put together, we should talk about what an Elixir application might look like that supports these concepts. So at the outset of the project, I identified 4 pieces of core functionality that I thought the application would require. And those include a real-time web API. This will get us the real-time behavior we need, as well as let our application run as sort of a client-agnostic game server, which supports the idea of this multi-modal set of interfaces. I had sort of 2 primary game clients in mind from the outset. There's like the adventure client and the creator client, and I decided that the creators, the ones that are actually building content for the world, would be best served through a web browser client. You can imagine somebody is booting up the main game on their living room TV or on their Nintendo Switch or whatever, and friends are gathered around, and they like flash up a QR code or something, and the other folks scan it with their phone, and they're good to go. I didn't want them to have to install more software to kind of get going. Yeah, so everybody has a web browser in their pocket pretty much, so let's try to use that. So this next thing, entity component system. This is a pattern that originated in the game development space, and it helps to organize game data and logic in a performant way, in a structured way. I don't want to turn this into like a purely game development talk, but I will go over some ECS basics just so we're on the same page. Okay, so imagine you are modeling a potion in your world, something that the adventurer can drink. So you might have some set of behaviors around being able to drink the thing. And then you decide you want to create a healing potion. So something that you could drink that would also heal you. So you sort of extend that behavior into something that you can drink and that will heal you. And then you decide that's cool. What about something that lets you jump really high or far or something? So you extend it again and make a jump potion. And maybe you see where this is going now, because what happens if you want a potion that could both heal you and let you jump high? You create a third thing, you can see where this could get like pretty problematic and messy pretty fast. So the idea of entity component system is basically that you throw away all that nasty inheritance and you deal in entities, which are really just like uniquely identified buckets of components, which are just data. And then just the existence of a component on an entity can imply behavior, which you use to define systems. So we see here that we're able to easily share functionality across these different things. So an ECS needs to be able to track these entities and which components they have, allow you to create systems to define the interactions between those entities and components, and blah, blah, blah. There's a lot that goes into it. But that's what I decided I wanted to start with. Yeah, and then the last thing is pathfinding. I knew I need some form of pathfinding. This is just so that non-player entities like monsters can find their way around the dungeon. So there's our initial sort of set of mission objectives, which admittedly seems a bit daunting. But the Elixir community is so smart and so generous. Let's find us some libraries. So for the real-time web API, any guesses here? Yeah. So yeah, if you guess Phoenix channels, you guessed correctly. Channels is robust and well-documented and often implemented as a solution for real-time communication over the web. That one was easy. That's sorted. For the browser client, Phoenix wins again. If you guessed Phoenix channels in the previous slide, you probably guessed LiveView on this one. In fact, you can build an entire game really in Phoenix LiveView, and you don't have to look too hard to find examples of that being done. So that was a pretty easy choice as well. Now, when it comes to the entity component system framework, I found a couple of really good options. Well thought out, well documented, and well executed. The one that clicked with me after some test driving is called Expanse. The other one's called ECSX, and it's also very good. There was a good talk about ECSX at ElixirConf US last year, which I recommend you go and check out if you want to learn more about entity component system in general or about the library. And then for pathfinding, yeah, it's just a library called Pathfinding. So easy. There's actually no shortage of really good Elixir pathfinding solutions because people got to traverse graphs. But I chose to start with this one. It was simple and it worked, and it's very aptly titled. But I can provide links to the other ones as well for sure. So we're back to this list. And with a little thought and a lot of help from the community, I was able to kind of turn this daunting set of requirements into this. Great. Round of applause for open source contributors and maintainers. Cool, so we're good to go now, right? Well, there's actually a fifth secret requirement that I've been keeping hidden from you this whole time. And that's a game engine. So I wanted the flexibility to build a primary game client, so the one the adventurer would be using, and a full-fledged game engine. If that doesn't mean anything to you, that's okay. A game engine is just basically a set of it's a software framework specialized for video game development. It usually includes things like advanced graphic capabilities and input handling and the ability to target different platforms and just stuff that you would need to do when you're building a game. In my current prototype, I'm working with some simple like 2D sprite-based artwork, but I plan to eventually move to a 3D rendered world, and this just makes that path pretty clear and obvious. For now, we can just consider this, though, another client of our web API. I chose the Godot game engine. It's awesome. It's open source. I love it. There are lots of other great options out there, though, to fit different needs and even skill levels. So now, actually, we do have this. This is it, though. We're done now, I promise. So we've got this great set of tools, and all we need to do now is make them all work together. So let's go through a scenario here, right? Player launches the game. Player spawns a new dungeon. And then goes about adventuring, whatever that means for us here. So this is a word of warning. This is my way of saying, hey, this is the part of the talk with code examples. I know some of you out there are pleased to hear that, and some of you are groaning, so you're welcome, and I'm sorry. Yeah, so let's, I'm gonna switch gears for a second here, and we'll try to do a little demo, because that always goes so well. Okay, so far so good. Yeah, so let me start this server up. And then I am going to launch the Godot game. Okay, so here we are. I know it's very interesting at this point, but we can see we got some interesting feedback here from Godot, saying that it's connecting to sockets and all that stuff. And in fact, we can see that something has connected to our API. Is that text? The text is very small, yeah? That's just maybe how it's going to have to be. Oh, now it's just gone. OK, well, anyway, it was there, I promise. So that was sort of step one of that, right? Player launches the game. Now player spawns a dungeon. So here's this lovely button that says spawn dungeon. So let's click that. OK, so now we see more stuff happening, right? We see our server saying that someone has joined this particular channel. And we now have sort of this representation of a little building to explore. Cool. So I'm switching back to slides, but now brace yourself. OK. I can't believe that worked that well. So this is just like a quick example of the system that we just saw that dealt with that like spawn dungeon action, right? We have the Godot application down there connecting to our server over a WebSockets connection. There was, again, hooray for open source. There was a really good Godot Phoenix channels client already waiting there for me to just sort of slot in. And so let's actually focus on what happens in that dungeon channels process. We've got a function here implementing the join callback, and it's extracting the dungeon ID, which is just a UUID that is generated by Godot. Letting the client generates this sort of delegates that behavior and lets them do stuff without connecting to the server. And it's calling this ensure dungeon function. So let's have a look at that, shall we? Here's that function. It's taking the dungeon ID we got and ensuring that a gen server exists with that ID. If not, it creates it in the second branch of the case statement here, but let's not get ahead of ourselves because now we know a little bit more about how this app is put together. A dungeon is backed by a gen server. So looks sort of like this, going one step up from connecting to the application. Now the channels processes are connecting to potentially a dungeon server. The job of the server processes here is to hold some important bits of state and to facilitate communication with the ECS framework, kind of consolidate that into a single place. But what if it doesn't exist? That sort of brings us to this second ensure dungeon branch here, where we can see the first thing that's happening is we are making this call to dispatch spawn dungeon. We're passing along this function's process ID and the ID of the dungeon that we want to spawn. And so it's like, what is this dispatch module? To understand its purpose, we must first understand that the ECS is a black box. Like, look, it has a lot of very important business to attend to. It has to like store and fetch data from an ETS table. It has to ensure synchronicity of certain data updates. And it simply does not have time for a developer to go in there all willy-nilly and mess something up. So we need to very carefully interact with this system as it's running inside of our application. Expanse supports an events system that allows us to sort of nicely ask it to do something without meddling with its internals. I've extracted out this dispatch module to handle that communication. It also gives us a nice opportunity to create test mocks around these dispatch functions so that we don't always need to depend on the ECS running for every test. So this is what the non-mock function, the real one, will do. We can see it just sort of lobs an expanse event over the fence with that same process ID and dungeon ID. And then I've set up an ECS system here called spawn dungeon that handles that event. You can see it pattern matches out those parameters from the event struct, and then does, as you can see, ECS stuff, which is like creating the dungeon entity, adding its necessary components, adding a player to the dungeon, like parenting it to the dungeon, and giving the player its components, and sort of like setting everything up and getting it ready to go. ECS stuff. I just let that code out because it's a lot. So then we send a message back to the process that initially interacted with the dispatch module containing our lovely new dungeon entity. And if we check back there in that ensure dungeon function, we can see that we're actually blocking and waiting on just such a message to come in. So what we do with that message is, we do some more sort of like setup stuff, create the initial room, that's that like room that we saw come up on the screen. We create the dungeon itself, and we start up the dungeon server. And then we return the dungeon server's process ID, thus completing the cycle. So this is sort of the overall pattern of the way most of this stuff is going to work. We have the dungeon server process that is going to be told by someone, maybe a channel, maybe who knows, to dispatch some event to the ECS. The ECS is going to do some work, and when it's done, it's going to send a message back to that dungeon server. I'm doing just like typical process.send stuff. I'm doing pub/sub for some things. It really just depends on the need that you have there. And so for the sake of completeness, let's finish looking at that dungeon channel join function. We know what ensure dungeon is all about now. So let's look at the next little bit here. We see we get some information from the dungeon server, such as the current room ID, and something called a projection PID, which I'll go into a bit more in a second. Then we use some of that information to find the data about the player that has been set up for that dungeon. This is using a cool feature of Expanse called projections that let you define sort of a set of components that you care about and some parameters around them. And then anytime one of those components data changes its internal state, it'll send a message to wherever you tell it to send a message to. So in this case, it sends a message to the dungeon server. So it's nice that we have that kind of set up there waiting for that sort of thing to happen. So yeah. Then we finally generate our reply payload. It's a message about the current room and information about the player and some other stuff. And the Godot client receives that payload and takes the appropriate steps necessary to render the state of the world according to the server. This is the full thing. I doubt anybody can read that text, but there it is. So in summary, the Godot client connects to the application via Phoenix channels. The channels module starts up a dungeon server if necessary. And it does that by sending an event to the ECS framework that tells it, hey, create a new dungeon and all the stuff that goes with it. And then the ECS does that and pushes a message back to the game client over the socket via the dungeon server and channel process. So it was really cool to see this working for the first time, I'll admit. But then what about this third item? Goes about adventuring. So there isn't much excitement to be had in the dungeon at this stage of the prototype, but there are a couple of interesting things for us to look at. So I'm going to try to repeat this 5-star demo swapping process that I did last time. Amazing. Okay, so one thing we can do here is move around. So I can just use arrow keys here to move around, and the interesting piece may be that you see that our server is receiving some events over the socket saying like this particular entity, right, has requested to move this particular direction, which is cool. The client doesn't need to know anything about what tiles are walkable, where the player could go, what's there. That's all on the server as sort of the source of truth. It just kind of says, hey, can I do this? And then the server says yes or no. So we can walk around and we can try to interact with this chest. But let me switch back over to slides mode before I do that. Oh no, my computer has locked itself. What happens if that happens? Okay, it's all fine. Yeah, cool. Yeah, okay, so, sorry for this sidetrack. The slide that I needed to show is this. It just says, what's in that chest? So I probably should have saw what was coming up and just not switched back. So I'm gonna have to switch back again now. But yeah, you got that great little bit of content. It would have been truly tragic to have missed that slide. Yeah, so what does happen if you interact with this chest? So we can walk around and choose to interact with this chest. And we can see a message come through here that says, hey, the container is empty. And that is because right now I don't create any items when the world's created. This is for this sort of like second type of player, this creator player. So let's have a look at that. Yeah, here we go. Okay, so this is just a web browser. Here's the dev tools. I'm not pulling the wool over your eyes. And this is running Phoenix LiveView, and you can see we get some options for how to kind of start doing this. We'll make a sword. Yeah, and yeah, it's a weapon, and it's glowing. Cool. So here is a sword we have prepared. We can go ahead and forge that, which will sort of create it at the world. And now when the player opens or interacts with the chest, we can see, aha, you've discovered an item. You've discovered Sting. So that's cool. That was cool to see working as well. So now I will switch back to the slides, hopefully for good purpose. Yeah, okay. So won't go into a huge amount of detail here, but the gist is that the LiveView client, since it's running directly on the server, it inserts its item based on the parameters that the player specified into an ETS table tagged with dungeon ID. And then when the system responsible for checking chests runs, wherever that needs to happen, in our case it happens in the ECS, it looks in the table for an item with a proper ID and processes the player finding it, which now just means logging that message, but you can imagine it would be added to the player's inventory or what have you. So where do we go from here? I definitely want to add a lot more game mechanics, kind of finish fleshing out this initial prototype. More creator tools, a room editor, like a level editor, and maybe like a monster editor, maybe some like longer form stuff, like maybe you can find diaries or scrolls or something. So a lot of ideas there, and I think this sort of framework I have set up right now makes that pretty easy to do. And then original art. But yeah, that's about it. I was really happy to get this up and running and get to continue working with my favorite programming language and tools. Makes it really fun to work on. With all that, I want to say thanks to you all and the ElixirConf organizers and all those open source contributors that make the world turn. I do plan to make this project open source, so keep in touch if you're interested. End.